Give it up for Matthew Renze. Shake your hand, and I will give you this.
Perfect. Whether you realize it or not, our world is going through a significant transition as we speak. We're entering the era of artificial intelligence and machine learning, a future where machines will be doing many of the jobs that human beings are currently doing. As a result, the software industry is also going through a significant transition as well. In the past, we'd have to program a computer step by step in order to solve a problem. This involves a lot of if-then statements, a lot of for loops, and logical operations. In the future, however, machines will be able to solve many problems. We just need to provide the data. And now, this is a radically different way of working with a computer than we're used to as software developers and IT professionals. There's a growing demand for people with machine learning skills. However, there's currently a shortage of people to meet this demand. As a result, those with the proper skills and credentials are currently commanding significantly higher salaries in the IT industry, and there doesn't appear to be any end in sight to this trend. The purpose of this lightning talk is to teach you a bit about machine learning, what it is and why it's important. So what is machine learning? In essence, machine learning is a subfield of artificial intelligence that's based on statistics. It involves machines learning how to solve problems, but without explicitly being programmed to do so. In essence, we use existing data in order to learn a function that we can then use to make a prediction given new data. For example, imagine we wanted to create a classifier for Corey to help him decide whether an image contains a picture of a cat or not. The first thing we'd need to do is get a set of images that contain pictures with cats and pictures with things that are not cats. We'd have a human being go through each of these images and label whether it contains a cat or something else. Then we'd take this data set of images and we'd feed it into this machine learning algorithm, the training algorithm, and it would look at each of the pictures and determine what it is about the picture that indicates whether it contains a cat. It's essentially learning catness. If we've done everything correctly, this machine learning algorithm will create a model that will allow us to predict whether a new image contains a cat or not. So when we feed this algorithm a new image, it will essentially determine whether this image contains a cat or something else. And now, while this is a vastly oversimplified explanation of machine learning, it essentially captures the essence of what it is that we're attempting to accomplish. So what can machine learning do? Well, quite a bit actually. We can do basic classification tasks, basic numeric regression, and basic cluster analysis as well. But now with more modern machine learning, we're able to do a lot of tasks and do a lot of tasks better than human beings. We can do things involving games like chess, Go, poker, 8-bit video games, communication tasks like language translation, object recognition, and a series of medical tasks as well too, like diagnosing certain diseases and recommending treatments based upon an individual's unique genetic profile. But there's also certain things that machine learning algorithms are not so good at doing. For example, they have a difficult time trying to determine whether an image contains a picture of a mop or a picture of a dog. And now, this might seem a bit obvious because some dogs look like mops and some mops look like dogs. But it's not just dogs and mops that these algorithms confuse. They sometimes have difficulty with other types of things, like whether an image contains a picture of a beagle or a bagel, or whether it contains a picture of a chihuahua or a muffin. And so you might be thinking to yourself, well, we can just tune these algorithms to just detect dogs, right? Well, you're right, we can, and this is what it does. This is a deep learning algorithm trained to only detect dogs. So essentially everything it sees in the world looks like some form of dog to it. Essentially the algorithm is hallucinating dogs right now. But that's just getting us started. In addition to basic and this more advanced machine learning, the new deep learning algorithms are able to not just take data sources from a variety of inputs, but they can also produce data in a variety of outputs, including images, text, audio, and video, which allows us to do some pretty cool things, like real-time object detection, image recognition, and image segmentation, motion detection as well. But not just classification tasks like this, we can also generate new synthetic data, like these synthetic celebrities. They may look familiar, but not a single one of these is a real human being. A machine learning algorithm generated these celebrities by looking at 200,000 images of real celebrities and synthesized new images to look like actual celebrities. And we can see this algorithm getting progressively better over time as it learns how to generate new celebrities. And check this out. All 4 of these videos are also completely synthetic. They were trained with a deep learning lip syncing algorithm. Oh, there should be audio here. Okay, well, this is where former President Barack Obama would have said something inspiring or clever that would have perfectly matched up to those videos. Essentially, they were completely synthesized from an artificial intelligence machine learning algorithm. On a lighter note, we can now use machine learning algorithms to help teach virtual bodies how to walk in a simulated environment. And once you can get these things to walk in a simulated environment, you're one pretty big step closer to getting them to walk in the real world. And I should note that this is pretty early on in the training set. This thing eventually gets so good at walking, you can throw a boulder at it and it won't even knock it over. It's actually better at walking than I am, which leads to stuff like this. Yep, we're in a lot of trouble. Well, I for one welcome our new robot overlords. In fact, I'm learning how to speak binary as we speak so that I can be of better service to them in their never-ending conquest for global domination. Don't worry though, robots still can't read reCAPTCHA yet. Thank you very much.